So again, good evening. Welcome to this session. The objective of the class today, we have well, on the heels of it from Sunday. So this is if we can go back and just look at Sunday's work a bit. We were here, right, looking at sign ups, right? As about the last thing we mentioned on Sunday, right? And of course, that is but that's very simple. A lot of operations take place at the same time, right? When work is being done, shutdown operation, contractor activity. Sometimes there's more than one contractor on a site. So simultaneous operations, right? Um, so on the heels of that, today we have lightning, which is, I mean, there's this lightning strikes and stuff like that, the hazards of that. Next to storage tanks, the fire triangle, generation and discharge of static electricity and how it is controlled, identification of ignition sources, how hazardous areas are identified and classified in zones, the classification of electrical equipment and tools for use in hazardous areas. So you can go straight to, I mean, I can literally tell you all of it, but that's not learning then. Learning is when we take you through the grind, right? And we have been saying for 2 weeks now, we're going to try to use the book a bit because I think it's valuable, right? I think it is. Well, coming to the end of the course, those who know me, I normally do that. To the end of every course, I normally try to use whatever book material they have, right? Um, so there's nothing really too much here. I mean, we all know lightning is a hazard by itself. They mention what lightning strikes are. A flow of electrons, of course, and lightning tend to get down to the ground because lightning, of course, is electrons. Electrons are attracted to the ground, which is protons, right? I'll read part of it. I think it's too easy for anything else. I mean, the thing here could be what is a hazard? Like, what's a hazard of, storing flammable liquids and stuff? And of course, if that tank is not earthed, if it doesn't have, like a lightning rod on it, which is a rod connecting, or the wire connecting to the ground, it could be susceptible to lightning strike, right? So lightning is an example of a major static electrical discharge from the atmosphere, that is. It is thought that initial charge separation is associated with contact between ice particles and storm clouds. So they say, I mean, that's just theory anyway, right? Generally, charges occur in areas of low electrical conductivity where there are few charges moving in this room. So when they say charge, you're talking about electrons, right? A flow of neutralizing charges may result from neutral atoms and molecules in the air being torn apart, then forming a separate positive and negative charge. Don't know if you know that, but that is what happens in nature. Um, atoms, atoms or atoms make up molecules or whatever. They said atoms and molecules there, right? They tend to be neutral, meaning that they are no charge. So they say neutral atoms and molecules in the air. But I suppose, I mean, I'm not too sure why, but and no one knows why because they call it a phenomenon. I think life happens to them and they become unstable, right? So you may have a stable um, oxygen molecule, which is O2, but then something happens to it and tears it apart. They say you're being torn apart. And when that happens, for those who know the bit of chemistry there, let me just put it here for you. The O2, which is oxygen, right? So that's oxygen in its stable form, right? But the O2, as I would say, life would happen to it. No one knows why. Maybe it's just nature, but it's torn apart. And when it does, each one of these carries a negative charge. So O2 is actually two molecules of oxygen. So when they separate, they carry a negative charge, and a negative charge is electricity. So you have enough of that, right? You'll have like I guess in that bolt then and that quantity then it'll be able to create, like lightning, right? So you can read all about that there. I don't think there's anything more. I don't think you're gonna get a question on what is lightning. I think the question here just is like what is a hazard of storing, like flammable liquids in tanks, and one of the answers is lightning strike, right? So you can read all about it here. um Let me see. The flashing of lightning is the visible static discharge coming to the ground. Why does it come to the ground? Well, negative, as life would have it, is actually attracted to positive, right? The opposites tend to attract, unfortunately. So lightning, if you have the discharge in the atmosphere, tends to come to the ground because the ground is actually positively charged, right? So that's how lightning. I mean, I've seen some footage, I think, on National Geographic showing lightning flashing up into the atmosphere itself. There must be some explanation for that. I mean, there must be some repulsion happening, but the majority of the time, lightning, comes to the ground because negative is attracted to positive, right? So the point here is that if you do have a storage tank, then that tank they should have like a lightning rod in it, and that's like a rod, but then there is a wire then connecting to the ground. So if the lightning strikes, then it will hit the lightning rod, and then because it's really electrons, the electrons will be neutralized by the ground so that your tank of diesel or gasoline or aviation fuel doesn't go up in smoke then, right? So that's why they take care of them anyway. So if you have anything about that, remember the technique we use in the book is that I wouldn't read every single line, especially with an hour-long class, but I'll do the explanation anyway, right? And then feel free to read up on it because it's such good stuff. But I think I would have done a fair good explanation there, given the fact I don't really believe that you're going to get a question on lightning. I think it's going to be the hazard, right? So the next thing is, of course, if it does happen, if there is a lightning strike, there is a possibility of a fire, right? And of course, those of us who know there's something called the fire triangle. If you all know it, it's right here. So the fire triangle consists of a source of oxygen. So you may have to learn this. They actually refer to it as HUF, right? Heat, here they have heat as energy because I guess heat is a form of energy, HOF. You have a source of fuel, right? Now that fuel could actually be the tank of whatever, the tank of diesel or whatever, but it could also be, I mean, this is not really meant for, the fire triangle is not meant for lightning. It's the fire triangle. So the sources of fuel could actually be wood, paper, leaves, whatever, right? Whatever you're burning, that's the source of fuel, right? Source of oxygen and a source of heat or energy. The thing about the fire triangle, as some of you all may actually know, is that all three elements must be present together. All right, all three elements must be present together for you to have a fire, right? And of course, if I was to go back into one of the other lessons, what you have to remember is that it's not really this alone. It's like everything have to be in the right proportion then. It have to have the right vapor to air mixed here. So even if they said oxygen and fuel, right? It have to be sufficient then to sustain a fire. It have to have sufficient heat. You could think of this as maybe if you are trying to I mean people don't really light fires anymore. But I guess if you are out there camping on the beach, which is not a good place to light a fire because it's too windy. But if you have had those experiences that are maybe lighting a backyard fire to get rid of some leaves, right? This is the dry season here in Trinidad and in Guyana, right? So lots of leaves then, right? I mean, even farmers and stuff may use that way to get rid of excess leaves and grass and stuff like that, right? But if you're lighting it, and you can think of it as if you're trying to light like like a compost heap then, right? And it's not enough heat then, so you're striking the match and it's not enough heat, right? Or it's not enough fuel, right? Or it's not enough air. So it's not automatic then that if you have heat, oxygen, fuel, that you'll have a fire. It must be in the right concentration, right proportion, right? So I don't think they do too much of that in this course. I didn't see it. Um, but remember that, right? It's not as simple as they make it out here to be done, right? So once the three of them are present in the correct concentration, then you'll have a fire. And of course, like the way you could actually prevent a fire is to remove one of these then. So like when we did trying to see, maybe if you know anything about purging using nitrogen, if they purge a tank with nitrogen and what they use and like what they doing, they taking out the oxygen. So if they take out one of the arms of the fire triangle, then you cannot have a fire, right? Of course, you can minimize your fuel content if that's possible. For some companies, of course, remember if they store, if that's their business, then if they store fuel and stuff and you can't get rid of it. But maybe because so, you can take out sources of heat, right? And in some books, they have this as ignition. So you can get rid of ignition sources. Ignition sources could be smoking. So the company could have like a no smoking policy. Um, Things like vehicles on the compound. If you have like gas, like LPG, LNG, you want to kind of get the vehicles away from them because the vehicle exhaust, then if it backfires, could become a source of ignition, right? So once you take out one of the arms of the good old-fashioned fire triangle, you would not have a fire. And of course, we're gonna look and see now that there are some set ways of doing that. For example, with your extinguishers, and let's go straight into that anyway, right? So nice reading, folks. Like I said, nice reading. So here we have heat, fuel, oxygen. So you see, they did use the word heat, right? They did use the word heat because like the British would normally say heat, oxygen, and fuel. So that's where I got the acronym HOF from, right? Classification of fires. So in this course, we're gonna use the sort of the European classification of fires, if you all know it. Now, it's a little bit different from the American classification, but at the same time, if you do know the American one, fine. I mean, they may just have to learn this one for exam, right? So the classes of fires, they have A, B, C, D, and F. I can make it a bit simple for your class. A fires is fires involving solids. So if you watch it, you would see, solids. I mean, look at right here, right? Wood, paper, plastic, right? Class B fires is fire involving liquids, petrol, paint, oil. You get the idea, right? Class C fires is fire involving gases. So you can think about as solid, liquids, and gases, A, B, C. Solids, liquid, and gases, A, B, C, right? Class D fires is fires involving metals, but the word metal here is not what you think. It's actually a grouping from the periodic table, right? So I don't want to draw the periodic table for you, but I'm not going to draw the periodic table for you. But for those who know the periodic table, it's according to like it have like four groupings then, right? Jeez, the marker, I've pressed the marker. Yeah, so the periodic table have like four groupings. They call them group one, two, three, and four. And according to the row, then the row have like a different name, right? So hydrogen is in group one, helium as well, right? I'm seeing here, uh, I think sodium, magnesium, aluminum, they could be in group three, right? So then we can say that group three of the periodic table are classed as metals, right? So sodium, magnesium, aluminum. Um, in a way, I guess these are kind of metals, but I mean, the word metal there didn't really mean to say aluminum because magnesium is not really a metal. It's just like when they say metals here, you could think of it like metals in the earth then, not steel. Like you could think of it as how we say gold is a precious metal, right? Silver is a precious metal. So that's where the word comes from, but it doesn't mean metal as steel, right? So sodium is actually a very soft metal. It actually cuts like cheese. Sodium is a bit dangerous, right? Most of these like magnesium and stuff, right? Is used like in gunpowder and fireworks, right? Sodium is one of the active ingredients they use in bombs, right? Of course, we shouldn't say all of that, but sodium, like if you have ever seen any um movies, television shows where you see somebody ring the phone, like like they dial the number of the phone, and when the person picks up the phone and says hello, there's an explosion. That is sodium they're using in that bomb, right? Sodium is actually the wire. So when the electrical signal goes through that, it ignites the sodium and it results a piece of sodium like the size of like an eraser could explode part of this room or part of your room, right? So the sodium is very explosive. In fact, it's not, they don't have it in the air. If you have it in the air like this, it'll just catch a fire, right? Sodium is actually stored under oil. If you store in sodium, they put it inside oil, right? To keep it out of contact with the air anyway, right? So class D metals there. Class F, fires involving cooking oil is now good old fashioned. Speaking of oil, good old fashioned oil like fryers and barbecue and KFC and stuff. A fire that dissolves there is called a class FI. If you notice, I'm going to stick to the notes a bit. If you notice, there is no class E, right? Now, however, the American system have a class E, and for the American system, C, I think, is electrical, right? But this is not the American system. This is the British/European system that your course is coming from, right? So you can have a learn of that. You'll notice that there is no E. So they say electricity. Like, how do you describe an electrical fire then? Like, what class is an electrical fire? Because it's not wood, it's not oil. I mean, liquid, right? But have oil in this too. It's not a gas, it's electricity. It's not sodium, it's not magnesium, it's not, frying oil. So I mean a lot of fires that occur from electricity, right? So how do you describe that? Well, they say an electrical fire is just an electrical fire. There's no E. So if you wanted to say electrical fire in the UK or in Europe, you just say electrical fire, right? As I mentioned there, the US system is a bit different, but we are going to stick to this one in this course anyway, right? How explosion fires occur. I think we mentioned some of these words last week's, well, Sunday. Detonation and deflagration, sorry. Deflagration actually talks about the height of the flame, right? The height of the flame is what they refer to as deflagration, right? So once you have all in the correct concentration, you'll have a fire. If you look at this side now, I would recommend that you learn this one, the stages of combustion, right? So, I mean, I would actually recommend, I'm gonna go back and show that that you learn the fire triangle if you don't know it. I recommend you learn the classes of fires if you don't know it. Um, I can see lovely questions with them. And of course, I recommend that you learn. I have seen this one. What's the stages of combustion, right? So it's about 5. You could try to learn them: induction, ignition, growth, steady rate, and decay, right? I'll say it again and we'll kind of touch them a bit, right? So the stages of combustion, induction, ignition, growth, steady rate or steady state, and decay, right? They have a nice little graph of them here. The induction process of the fire, the growth of the fire is maintained and then the fire dies back down, right? The stages of combustion. Please, please, please learn this one, right? Let me just touch. I won't read all of it, but ignition is pretty short, so maybe you could read all of that. We'll touch, a next piece of it and next piece of it again, right? So the point of ignition is reached when the reaction becomes self-sustaining and no longer requires an external heat source, right? So think of you trying to light a fire. It will start to light then when the vapors and the air reach that correct concentration and the fire could keep on going, right? At this stage of combustion, develops very quickly and there's a dramatic increase in the temperature as the fire growth. Once ignited, the fire may spread through direct burning or through the typical mechanism of heat transmission, convection, conduction, or radiation, or that in itself is something you should learn. right? That's the means of fire spreading. Convection is through the air. Conduction is like the materials in contact with each other. So I'm thinking about like a compost heap now. So if you have, I guess paper there, and you have leaves, and you have branches, and you have cardboard inside there, a compost, right? Nothing that will cause harm to the environment, right? Shrubs, right? Those kind of things then, right? So that could burn because that would actually form, that would actually form, like uh, a biodegradable aspect of it then back to nature anyway then, right? I mean, you're not really burning anything like plastics, right? Leaves and stuff would just, if you burn leaves, it burns, with a white smoke, a white soot then. But if you burn anything like plastics or rubber, anything that's kind of foreign, it burns that, kind of darkish smoke anyway, right? So the ones that are good for the environment. So nothing is wrong with a compost heap. That's actually a way to get rid of excess, leaves and trash. But of course, biodegradable trash, right? So conduction is like if you're having, I guess, a cardboard box is on fire, but then that makes contact with a branch, which is in contact with another cardboard box, right? That would be, what is called conduction, right? Radiation is the transfer of heat through far distances. Again, I mean, like if you have been around a fire, like like a garden fire, then why yard fire, you can actually feel the heat from a distance. That may be said to be radiation, right? The rate, scale, and pattern of growth depend on a number of factors such as the nature, form, and the amount of fuel. So when they say fuel, please remember it's not gas they're talking about. They're talking about what are you burning? Is it leaves, shrubs, cardboard boxes? So the amount of that you have, then the more flames you'll have then, right? Availability of oxygen, where we don't really have too much problems with that. Amount of heat produced by the reaction, right? So steady state, after the growth period, the temperature stabilizes. You'll actually see that the flames go up and then the fire will kind of keep on burning. And the combustion process reaches a steady state where the reaction between fuel and oxygen is balanced until all the fuel is consumed, right? Or all whatever you're burning has been burnt up then. Decay. I think I went a bit too fast. So decay will begin when either the fuel or oxygen has been consumed, the fire will extinguish and gradually cool down. In the early stages of decay, there is still a considerable amount of heat. There is certainly enough to cause reignition if more fuel or oxygen is supplied. In the latter case, admission of oxygen, opening a window into the oxygen depleting room can result in a sudden explosive reignition of vapors. But that's if that's what they're talking about. I mean, I think we have all if you have actually done barbecue on the outside, the traditional kinds, you could actually use, some sort of material if you have it, I guess like newspapers or and you could sort of fan the flame or fan those coals and you would see it. So you could actually put oxygen back in there, right? That would reignite if, a fire was on the down low. And even if it's some sort of coal or wood you were using and those have burned up, you could actually add more coal or add more wood and you're gonna get your flame going again, right? Like I said, a lot of people do that now for outdoor activities anyway, right? So that's it there for that. Electrostatic charges. I actually didn't feel to do that again. The reason is because it's the same thing as what I had here. That's the same thing here. Like molecules, atoms would become unstable. I read it for you just now. I read some for you. And when they become unstable, they have a certain charge. The amount of charge that flows or builds up, could be said to be electrostatic charges, right? So um, I don't think that was anything that was hard. If the charges build up, now there are some places they can build up on, like a worker's coverall. Not too sure if you know that. Like based on your coverall, you can actually pick up charges. And if you get close to like a diesel tank and the tank is not earthed, the charges could jump onto the tank, thereby creating a spark. That spark could cause a source of ignition anyway, right? it's not that bad. You'll have to have a flammable atmosphere for that small spark to ignite a fire. Like you may have to be working in a gas plant or something, and it must have had a leak or something, right? Because other than that, electrostatic charges don't really cause much explosions unless if there's a flammable atmosphere, right? Like a time I saw one with a petrol station. You know, when you go to put gas in your vehicle or petrol, they would say switch off your phone. I actually try to do that. I mean, I don't switch it off, but I try to leave it in the car. I don't really go by the pump with it. But I did see a video of someone. I think so they would have been pumping gas or petrol. And I think at the same time, because if you look at gas, right, gas is called gas because it is a gas, right? Gasoline is called gasoline because it exists in a liquid state and a gaseous state, right? If you doubt me, don't doubt me and don't try, right? Don't don't try it, right? Don't try to. Gasoline is different altogether. Gasoline is different from kerosene. Gasoline is different from diesel. It's a different liquid altogether. It's actually called gas, right? Like if you were, doing a barbecue or something and you're using kerosene, fine, right? If you sort of in your garden or in your farm, whatever, and you're using, kerosene, diesel, fine. Gasoline is a whole other substance altogether, right? If by some madness you use gasoline, right, and you ignite a fire, like in terms of a static, but I'm saying here, it like in terms of gasoline, and it creates a vapor, right? So you could have like you could be close to like a petrol station then, right? And not close to the pumps. But if the vapor is there and you do have static discharge, it will be enough to explode the entire petrol station, right? So just remember that, like gasoline is classed as highly flammable, not just flammable, right? And you don't have to be, if it was spilled then, if God forbid, if you ever see, just take it from me, if you ever see spilled gasoline, just run, right? Don't go close there. Don't say, okay, the gasoline is at the end of, like the end of a property, whatever, and you light up a cigarette, right? Because gasoline is different. It is a gas, it spreads in the air, so you might even see it, right? That creates a blast wave, and the wave is going to run through you. The wave is going to go right back to the source of that gasoline and ignite the gasoline, right? It's not something like kerosene, and it's not. I know many of us mightn't have the, if you're a firefighter and stuff, maybe some firefighters, I remember teaching some firefighters in Tobago, they never had the experience with it, but it's not the same. It's highly flammable. Don't ever play with it. Don't ever play with anything flammable. But kerosene people get away with because kerosene is very common in the Caribbean. And we use it. Diesel, we use it quite a lot. Kerosene a lot, right? But gasoline is a bit different, right? Because like I said, it's called gas for a reason. And I'm saying here, the buildup of electrons on a worker's coverall may be enough to produce a spark. Now, that spark in the normal air mightn't do anything, but in a gasoline vapor enriched air is enough to cause an explosion, right? So, static electricity is generated by process activities such as mixing, pouring, pumping, filtering, or agitating liquids at the rate of generation. It's determined by conductivity, turbulence of whatever you're mixing. So static electricity have to do with two things rubbing off on each other, right? And so whenever two surfaces, if you think of like maybe the worker's coverall, and the worker is leading up on a tank, he's leading up, he or she, they're talking, they're rubbing on the tank, and probably sometimes unknowingly, they lean up this way, they lean up that way, they lean up this way, right? So whenever that happens, we are form of energy as well. Even though we are more hard, we are more like a dense form of energy, right? But when you rub off on a tank or you rub off on whatever wall you're leaning up against, if it's metal, you leave part of your energy there. That's what has happened. Your molecules are being stripped out, and you or the material is going to retain a charge. if you have a coverall, the nature of coveralls is that they retain a charge on them. So the electricity builds up on you. It's called static electricity. And as I said, if you come next to somewhere that has like a fuel source and the thing is not earthed, because it's electrons and electrons are attracted to protons, the electrons could jump onto the tank. Now, when they do that, they create an arc or a spark. That's what it's called, like an arc, right? And that arc is enough to create a slight uh, source of ignition, right? You know where you see it a lot? Like for those of us who have no experience in what I'm talking about here, you know where you see it a lot? You may have seen it or you may have felt it. Um, when you dry your clothes, if you have a spin dryer, have you all ever done that? Have you all? Well, I know the Caribbean is very hot, so most people don't do it, but maybe in the rain season, if you have a dryer, most people have a dryer, but they don't use it unless it's the rainy season, right? But have you all ever, like if you have your blankets, like you know, like your woolly blankets, and if you spin dry that, because the spin drying process, it's all that mixing, it's all of that rubbing off, right? And if you have your blankets, if you just got it back from the dryer and you took it to your room and you take off your lights and you open it, you'll actually see, you'll actually feel yourself getting shocked because the process of drying would have knocked off the molecules and created a charge on your blanket. Of course, at home, that's okay. But what if now this blanket, well, I mean, it's a blanket. I don't think it could be anywhere else. But I'm saying, what if it was some sort of flammable atmosphere? That spark that you feel may have been enough to create an ignition source. It remains to be seen if that ignition is enough to cause an explosion. There isn't too much examples in the world of static electricity causing full-fledged explosions, but they have some, right? And they have some examples like the one with the phone. They have one, I know there was one in the UK at time with um, a fire extinguisher company. How strange is that? A fire extinguisher company created the powder by agitating the powder and I pick up a charge. And I think that met a source of, had to be a source of flammable liquid or something. And the company that has created the powder to extinguish a fire caught a fire. Life is sort of strange, isn't it? Right? That's about the only one I could think about. And that's an old example. I use an example more than 10 years now. Right? Static from TV, yes, very good. Yes. So like if you put your hand close to your flat screen, you probably will feel it. You'll see like the hair in your hands going up and stuff. Now, again, like I said, this is something a bit more theory-ish to say that if these things are enough to cause a source of ignition, it have to be that the air is rich with fuel, which means it have a leak. And if it have a leak, some gasoline tank or something, right? Remember, you don't have to be close to it because the gasoline forms a layer of vapor then, right? And that could saturate the room, right? I do have experience with it, one that I survived, in fact, right? But I mean, like if a propane tank was on fire, those things, I think I mentioned some of that thing on Sunday, right? But it's nothing that would happen in the normal atmosphere, then you really do have to have some sort of flammable atmosphere. So identifying ignition sources. Ignition sources could be anything. Ignition sources could be, I mean, I could take some from here. Just give me a minute. The internet is giving trouble. So we have smoking could be a source of ignition, hot surfaces, welding, right? Spark some heat from internal combustion engines, open flames, right? Nothing too hard there. Nice read up. So I trying to kind of set the tone for you. So like when you get in the book now, you know it's not that difficult anyway, right? So control of vapor phase explosion. I do actually like all of this. I like all of them. Um, so let me just run through them with you. So how do you control now? Um, no, I like how they said it. They said vapor phase because they didn't just say fire because a fire, remember, is really vapor and air. So the proper thing really to say is, controlling, like a vapor phase explosion, right? Because fire is in a sense that a fire doesn't burn unless you have vapor mixing with air, right? So how do you control any such explosions? You have proper process design and control. right? So this may be on certain plants that they do have, they have pressure resistance equipment. They have, keeping the concentrations below the flammability limit. They have things here like, so some nice controls here. Isolation. Isolation can be many things, to be honest with you. So the book isn't too clear on this, right? And isolation could be like if there's a valve feeding, like fuel into a tank. Well, close off the valve, that's isolation. But isolation could also mean like they have sent the reactants into some sort of neutralizing chamber then, to kind of deal with it, right? But I like what they said, their proper design. What I had in mind here would have been good, steady materials. Like if you talk about a building, and the building should have had fireproof doors, so that would have been designed. The walls would have been treated with fire-resistant materials. That would have been designed. If you are a safety, a worker, and you're working next to or in a flammable atmosphere, you should have on an FRC coverall, a coverall that the fire resistance is built into it. Fire resistance, the coverall has been treated with a fire resistant material. So control by design is a good control, but I would have prefer use my own examples here, right? Structural protection, incorporation into building designs that can reduce the effects of vapor phase explosion on occupants. And that would probably be relief panels, right? Or again, maybe a fireproof door, fireproof enclosures, all of that would be structural protection, right? There is a type of material called intumescent material. Not sure if you want to write it down. There is a type of material called, and you have it in your home, right? Intumescent, Intumescent. There's a type of material called intumescent material. You have it in your home. I'll tell you where just now. Some of us know already, right? Because some of us did this in process safety. But um, like structural protection then, like in your oven, in your stove at home. I've always tell students, if you all think about this, about the stove you have home, right? That oven you have could bake a cake, bake turkey, bake chicken, bake pork, bake whatever, macaroni pie, right? And you put the oven then on temperatures like 350. You put the oven on temperatures like 450, right? What you don't know, or what some of us know, is that 450, right, is enough heat to totally melt like a steel beam. 400 degrees Celsius is enough to start to compromise a solid steel beam. So the question is, well, why doesn't your stove burn to the ground? Because if you're strong, you could probably pick up your stove as a male then, right? I mean, I'm not a female, but but you could pick up your stove. But how come at 450 you're baking whatever you're baking for 4 hours and then your stove is good? What's even worse is that if you open your stove and you watch the grills in them are very, very thin. So how is it I'm saying that 400 could melt a steel beam, but these little grills in your stove isn't melted and you're using it for years? Well, the answer is that is intumescent material, right? The grills of your stove and the inside lining of your stove is intumescent materials, right? So think about if there was going to be an area where it was going to be, like a furnace or whatever, I mean, a steel furnace in the steel industry, the area around there then should have been also treated with intumescent materials so that it could withstand in the event of an explosion, as you had in here. Watch an explosion. That the walls of the offices then, and the walls that kind of get to that furnace would have been structurally protected. The other answers are kind of easy, right? Segregation and storage of materials, right? So you try to kind of store flammable materials away from the rest of the building. Inertium, we mentioned that one. That is like using nitrogen to get rid of the oxygen. Because once you have no oxygen, you can have no fire. Explosion relief devices, these could be fitted into the building. This is like a relief panel. If you want to get take off this diagram, and I don't know if I did that one for you before, you may want to kind of learn some of these. There's one called Burskin disc, right? Let me try to show you what that one is, right? But relief devices then, right, are very good devices anyway. So I'll draw something like a furnace here. So if there is like a furnace here and you wanted, I mean, so the like the flames then through this would have been controlled, right? I mean, you don't want to flare every single thing, right? So the flame there would have been controlled. But what if the pressure increases? If it's a Burskin disc, what they'll have like there is like a break in the wall here then of the furnace, and they have a device here. Now, if it's called Burskin disc, it actually does look like a disc, right? But this here now will open or burst open and lead into like another chamber that will probably neutralize any extra pressure or heat that is getting into that furnace. If by some means there is some runaway reaction and the temperature here starts to increase more than what it's supposed to be, this this will actually burst. It's meant to open. It's going to blow open, and the excess heat, pressure, whatever it is here, would have gotten into like a neutralization tank. Some people call it a blowdown facility, and that would have been dealt with anyway. So things like explosion relief devices, please try to learn some of them, because some of them could be a panel, some of them could be disc. If it's a panel, the panel will just open. It wouldn't really blow out. It's like a hinge then. It'll be hinge and the hinge will just open, and the excess heat, pressure, whatever will get into your blow down facilities, right? Of course, controlling the material quantities is very good. They mentioned store as little bit as you need. In fact, what they recommend storing only 1 day's worth, right? So I'm not too sure if that's even possible for some companies, but you store, so you don't overstore chemicals, and you don't have, like 12. I mean, and that's kind of, I mean, if your company has a chemical storage shed, that may be different. But the idea here is that wherever work is being done, if you have welders or whatever, right, that hopefully they're not welding in the chemical storage shed. And if they are, the barrels and stuff should have been moved out. They should have been moved out. They should have been emptied, right? You shouldn't have anybody inside there that you have full chemical barrels and stuff inside there, right? So the idea is to store just what you need, for one working day anyway, right? They get so look, they have it here. The guiding principle is that only the minimum quantity needed for frequently occurring activities, or that required for use during half the day or one shift. So you store what you need for 1 day. Don't store 20 barrels of diesel when you know you just need a bucket of diesel for the day, right? So especially when the work is being done, right? So I mean, like hopefully, like I said, the activity itself is not being done in the chemical storage shed. If it is, but then we need to empty that chemical storage. And if somebody was welding a door, they welding up the roof or something for the chemical storage shed, the barrel should have been moved out, all 12 should have been moved out. If you just want to have just maybe a gallon of diesel there, maybe for some companies use the diesel to clean up your hands and stuff, or to clean up parts and equipment when the work is done, fine. But only store what you need for like 1 day. Did you all see that here, folks? It's very good suggestions here now, right? Segregation, inerting, explosion relief, storing what you need for 1 day. I'll tell you, it was a simple lesson, but at the same time, I'm trying to walk you through it now. And I trying, like I said, psychologically, there's something happening here, which is I'm trying to get you not to be afraid of your textbook, right? 7:15. So looking at what we have to do. So I think I'll talk you through this one. And I would just sort of touch it a bit. It's right here, so there's nothing for us to really go. I would have liked to finish here though. like we don't finish it, this would be kind of odd to start on Sunday because this actually ends off that. It's kind of odd to start it on Sunday. I'm gonna try to finish that off, right? So here the thing though. Let me try how simple I can do this for you all. So in the UK, right? There is a law, well, a couple of laws. One of those laws is a law called COMA. There's another law called COSH. Well, that's just the acronym anyway. COSH stands for the Control of Substances Hazardous Health Regulation. COMA, the Control of Major Accident Hazard Regulation. And there's actually one called DSA, the Dangerous Substances and Explosive Atmospheres Regulation. So a couple of laws. Now, what those laws did, they made it a requirement for the employer to classify the areas where workers are working, right? So I say that again. Those laws, especially things like DISA and COMA, right? They require the employer to classify the areas where a worker is working. So let's think about a petrol station, a gas station. Well, we say gas, but the proper thing is petrol, right? So let's think about a petrol station, NP, right? Guyana Oil and Guyana or Shell and Guyana, right? I think Trinidad really do need more gas companies, like gas station companies, petrol station companies. Guyana have a lot. You can ask Devon. Every petrol station you go to Guyana is a different petrol station. Trinidad is just NP and probably Unipet. But they do have it a bit competitive in other countries. Barbados too, Shell. Most of the other Caribbean islands is like Shell or whatever have you, right? Any one of those ring a bell there, Devon? I can't remember all of them, but I know Guyana have a lot. Do you remember any? I don't know all of them. And I think I know Guyana Oil, Guy Oil, but I know there's 100 other gas stations in Guyana.
Yeah, Guy Oil, um, Shell.
Shell. It has some weird ones too, like just like small companies, I like family-owned companies or something. Like they have lots of different gas stations that are maybe that's what Trinidad need to kind of get the gas prices, kind of under control. Anyway, so let's think about a petrol station, right? Now, what I'm saying, if you want, I'm just gonna get down in this one time, right? Because of the time. So what the law did, the law actually had two classification. So one of the classification, give me a minute, I'm gonna pop up on the screen. So one of the classification is for gases, and another classification is for dust. So I'll just put G and D, right? Gas and dust. They have it on the slide and I have it right below here, right? So gas and dust, right? Look at here, gas. But you probably not, I mean, you probably didn't see it because that we haven't read it now. Look at here, dust. And if you look here, you'll see gas. Watch it, gas, and you'll see dust. Everything is gas and then dust. So there are two classifications, one for gas, one for dust. Anyway, so the classification for gas is 0, 1, and 2. And the classification for dust, remember this is summer law, is 20. We can mark that better for me. 20, right? 21 and 22. 20, 21, and 22. And what the numbers mean, the numbers up here that it means that you are working in that type of atmosphere, that you are in it. So if you think about a petrol station, we can probably say like if the delivery trucks have come and they have opened the underground storage tank and they are decanting gasoline from their trucks, trailers, tankers to the underground storage tank. The workers that are doing that, you can say they are in a zone 0 atmosphere. If it is gas, if you're working like in a steel plant or something and you are right where all the metal dust is, well, then you are in a zone 20. They call this zone. So if you're in it and what you're dealing with is a gas, it's called zone 0. If you're in it and it is a dust, like a steel plant or a flour mill, and you're in where the dust is actually being mixed, where the flour is being mixed, where the grain is being mixed, they say you are in a zone 20. If it's dust, and if it's gas, remember it's zone 0. If you're likely to be around it, I don't know if you're right. And if you so look at right here, likely. Look at here, likely. If you're likely to be in it, Then they say it's a zone 1 if it's a gas, or zone 21 if it is a dust, right? So if you're likely to be in it, for example, like the pump operator now, the pump attendant in the petrol station. Now, the gasoline is in the pump, whatever, right? The only way you're gonna get it out of there is if you squeeze the nozzle anyway, right? So the pump attendant is likely to be affected by the gas, so that's a zone 1. And I guess maybe if you are an operator and you're working close to where the dust is, close to the mill, close to the steel plant, you're in the yard, but you're not quite upon where the process is at or where the process is going on, you are said to be zone 21, right? And if you are far from it, if you're unlikely to be affected, if it's gas or dust, they say it's zone 2 for gas or 22 if it is a dust. So you can think about the you could probably think about like a neighboring business to the petrol station. God forbid if the petrol station is on fire, the neighbors, so let's say kind of far away. I want to say maybe uh 10,000 square feet away, which is like 2 lots of land. You mightn't be too affected, right? And therefore you are said to be, like in a zone 2 atmosphere. And if it's dust that you are in, if it's a big steel plant and you are a neighbor to the steel plant, maybe you could be affected, but let's say you are far from it, you're unlikely to be affected from that type of explosion. You are said to be in a zone 22 atmosphere. Now, what you're going to have to do, you may have to learn these here. For those of us who don't know it, is that some of us know it already because of the degree course or the process safety course, right? So for gases, 3 zones are used, 0, 1, and 2. For dust, 3 zones are used, 20, 21, 22, and it all depends on if you're in it, likely to be in it, or you are far away from it, right? So Sunday when we start, I'm going to ask you, for those of us who would have learned this, right? If you learn it anyway. To end off, I want to end off with the different types of tools. So if you are working in that type of atmosphere, they recommend that you use certain types of tools that are like fire, well, not really fire resistant, but tools that are intrinsically safe, tools that are fireproof, or tools that are catered for that type of environment.
Intrinsically
And we
safe.
have them here. Intrinsically safe, yeah. Intrinsically safe, type 1. They can have it here, right? So if you are working, I mean, I'm just saying, if somebody is using um a screwdriver, right? Like you could use tools then that would not create a spark. You see that it's like a type E equipment. Type E equipment would not create a spark, right? Type D is flame proof. I just cannot tell you, read it up for yourself. And then type I are those that are intrinsically safe, right? Maybe I'll read one for you, but I have one under here. So let me read the other one for you. Type N, non-sparking tools, right? So less stringent requirements have to be met by this category. You could use, compared with the type E equipment, it is intended for use in zone 2 applications. So you use one that is a non-spark. Zone 2 is like, it's likely the gas is there. So you kind of want like a non-sparking tool anyway, right? This is a good control, or these are some good controls I recommend too if you don't know these, to commit them to your memory, especially intrinsically safe. You can probably commit 2 to your memory if you don't want to commit all 4. I'll probably go with type E. If ever I had to pick a man, I'm going with type E and type I, sorry, and type E, right? But you should know, you remember like a NEBOSH question, maybe 8 marks, they could ask you what is 4 controls. At the same time, the 4 controls don't have to be on equipment. You could go back to the controls from saying safer design. You could go back to the controls from saying segregation. You could go back to the control for saying use, intrinsically safe equipment. You can go back to the control of saying explosion relief devices, and you get your 4, right? So we finished. We finished, right? We finished. I reached where I wanted to reach. So Sunday, this is boiler operation, but also it's not just boiler operation, right? This is going to merge into something else here, something that is not too difficult again, but we have almost started the second to last chapter. Sunday, we started. Boiler wouldn't take us more than 50 minutes to do. Like we just out of time today, right? This is chapter 4 here, right? Fire and explosion, really good stuff, right? And after this is just one short chapter after this. Nothing hard here for those who went through this before already. Heat detectors, different ways of, protecting it. Look, the intumescent word up there, intumescent materials, right? Some nice stuff, right? Nothing too difficult. Active and passive fire protection. That's a Sunday. We'll pass all of that on Sunday. That isn't really hard. Types of extinguishers and stuff like that is also Sunday, right? Yeah. You'll see it's not very hard. I will probably finish off this. Emergency response is not the COMA regulation I was talking about here, considered major accident hazard regulation. Right, and that's it. And once that is done, I intend to finish this on Sunday. We'll talk through it a bit, right? Once that is done, we would have our last chapter to go, which is chapter 5, right? Logistics. And if you have some time run through this too, this is very short too. This is like the shortest chapter in the book, right? So we'll see where Sunday reaches. If we don't get to finish, we'll finish chapter 4 next week, Wednesday, and then we have maybe 2 sessions after that, right? So we are done. Let me stop it there and get it roll. And that'll be it for today anyway, right? We have had, let me see. Let me see. 7 Sunday was the 17th. Yeah. Did I
Yeah.
update the
So
rule for Sunday? Yeah. I think I had written down the rule manually Sunday as I say that. Yeah, I actually didn't record the rule for Sunday. So I'll leave a space now and I'll record it now because I did actually manually write it down. Write it down. Any questions from me, anybody? But the idea here, folks, please start studying. Lots of stuff, we talk about, but are you committing them to memory? I mean, and so that's the thing with this course anyway, right? All right,
I
Akash.
posted up the video for the static explosion in Kansas from
Yeah,
CSB, so they can have a
very
look
good.
at it.
Yeah, excellent website. Yeah. Akash is here today.
Present, yeah.
Okay, thanks very much, Akash. Let me see it come this way, Okay. All right. All right. Chanel Ryan.
Present.
Yeah, Rashad, thanks very much. Rashad Thompson.
Present.
Rashad is here on Sunday. Let me see. No.
Yes, I was.
Yeah. Okay.
Yes, I was.
Okay. All right. Jessica. No. Naveen.
Yeah.
Okay. Naveen. Jessica Alfred.
Present.
Jessica Nigel Smart.
Present.
Yes. Yes. Okay. Crystal Thomas is here. Alicia. Alicia.
Alicia, right? Yes.
Yeah. Okay. Yes. Alicia. Yeah. Yeah. Okay. Christopher Gobin. Yes, I'm seeing
Present,
Christopher's name. Hi, Christopher. Alicia Kayan.
Present, sir.
Thanks, Alicia. Alim is not here. Stephen. Stephen was actually here Sunday. Stephen. Raven. Once you say present, you can leave, right? Raven. No. Devon is here. Cohen Batiste. Okay, Cohen said present, right? Okay. Anybody on the live did not say any name? I have Crystal, I have Devon, I have Cohen, I have Rashad, I have Chanel. I think I have you all anyway, right? So that's a wrap, folks. I'll see you all back on Sunday. I'm gonna try to, when this video finishes, try to put it up tonight, right? As much as possible because the day is be so busy anyway, right? Once it finished converting, I'll try to post them up on YouTube on time tonight, right? All right,
So
folks.
before you
Huh?
leave, sorry, I was waiting for you to finish call the roll.
Yeah, go ahead.
With regards to the textbook, you have any updates on that?
You could probably message me on that privately. The issue we have with that is we have had limited um foreign exchange to use then as any business in Trinidad right now. And we are we have to use whatever we have to pay for exams, right? Because we can't deny people to write the exam. But once we use, all businesses have a limit, right? Like meaning that once we use, then we can't use beyond the month again. So every month for us is an exam. That has been something on the back burner anyway. But we did make sure to give you
Right.
all the e-textbook. But for us as a school and the country that we live in now, because of the restriction on foreign purchases, our main focus is paying fees to NEBOSH for exam. Because if we don't do that, then you don't get to write the exam. Second will be buying books anyway. So that is the issue. And it happens month after month. We are conscious of it. But at the same time, like with this class, we made a decision to purchase the books for process safety. Was either purchasing your book or process safety. Given the fact you all have a textbook, we decided that we can't purchase it too because of the foreign exchange. We decided to purchase what we
Okay.
could purchase anyway. So that is a kind of technical thing. We never had these issues before, those who know us, but it's not that we could do, it's just we as a company cannot spend more what the government have said that we cannot spend on foreign
Okay.
purchases anyway. Yeah, so that's the issue
Mm-hmm.
there. All
All
right,
right, no
folks.
problem. Thanks.
Right. So all the best for the rest of the night. I would see you all back on Sunday.